Hello brothers and sisters of internet. Today I will be reviewing logs again. There is one video on our channel reviewing logs and I thought I'd review it right now. So here it is, we are back at compounding interest. Now if you remember from my very OG videos, compound interest is AT, right, equals to P1 plus R over N to the power of nt, right? Now here we have the rate, interest rate, and we have n, which is number of times per year, right? And we have t, which is times per year, right? And we have price, and then we have the total amounts that we're making, right? So here, that the first approach would be to just plug in the numbers we have. It's going to be worth this much. We have an interest rate of this much, and we have a price of this much, right? Let's just plug that stuff in. We got to 20,500 equals to, what's our price? We got 7,000. Now this is called compounding interest, and this is for logarithms. So 1 plus 0.08, right? Because it's 8% over 100, so we just do 8 over 100. 8 over 100 is 0.08. 0.08 over number of times per year. Number of times per year, it says quarterly. When it says quarterly, it means most likely 4, because 4 is 4. There are 4 quarters in a year, so yeah, that's why I know. And then t, so we need to find this thing. We need to find t, right? So I think the first approach to make here is straight up divide 7,000, right? You got to divide that to both sides, right? And then what that gives you is what's 20,500 divided by 7,000. That is, what number is that? 2.9293. Let's just do 93 because it's rounded. All right, now we just have to add this. So 0.08, so 1 plus 0.08 divided by 4, which is 1.2. Same thing goes if we do it this way, divided by 4 plus 1.02 to the power of 4t, right? All right, so now the goal for us here is this. We have to log this thing. So log it. So here, log, we bring it here, and I'm gonna do like, okay, the base of this is the base of the log. So you could go ahead and say, well, log base 1.02, right? And then we got a 4t, right? So 4t would just be, that would be to the power. 4t would just be there. So it would be like, yeah, 1 over 4. And this part, because this one goes in front. The power normally goes in front of the logs, right? And the base is just the base of the log, right? And this one is just the argument of the log. So it's just this, and then you got the argument, which is 2.93. That is the log for this thing, right? But now, right, we need to find how much it actually compounds, and that is when you plug this into a calculator. Yeah, just plug this into a calculator and you'll get the answer. The answer is roughly 13.56. That is what you'll get. This is a calculated question 100% on the test. this is a calculator question. You need a calculator for this. But this is how you solve it. You turn it into a log, you turn a log into a decimal. And that is how much time it will take. Right now we go on to condensing logs. And condensing logs is pretty easy. So this is log base. Like this is just common log. It's log base 10 because there's no base here. So there's no base here. It's just log, common log. So you just put log, right? And then you put parentheses, right? And then you look at the signs, right? If it's negative, that means it's a denominator. So it goes below. So you got a Z down here, and then you got positives. So these positives, this is just A, right? Base. So this is not base, but this is the argument. It's the argument. So A, right? Argument here, right? And then to the power of 2, right? Now that's A squared, right? And we do the same thing for this one. We got B as an argument, and then we got to the power of 1 over 2. Now, honestly, I just write this as root. I just do this thing. I just do root B, done. We got it. Now we have to expand a log, right? We condensed the log, and now I have to expand a log, right? And when you expand a log, it goes something like this. You look at the base of the log that's outside. You're like, oh, bro, these are like multiplying each other. So in your head, you're like, okay, if they're multiplying, then they're supposed to be adding in this expanded form, right? So if they're added, they just added their they're just addition. If they're multiplying, they're just addition. And if they have a quotient, if they're a quotient, then they're minus, right? So let's try with this, right? Log base 2, and then you got a 7 here, right? So you just put it here. Now I'm thinking, no, you can't simplify this. Yeah, in some questions you're expected to simplify this into a number that can satisfy the argument. So like if you're trying to satisfy this argument here, and if you don't, then you're gonna get it wrong. You're gonna have to like put like a number for it instead of a log. But here anyways, we just put 3 log 2 x, right? Because 3 in the denominator came in front, right? X came as the argument, right? And 2 is just the base of the log outside. So put it here, and then we do another plus because we got a y here. So we got 4 log base 2, and then we got like a y out here. So you just put a y down here. And that's how you expand a log. Easy as that. We move on to the solving part. So, okay, solving, this is something called common base, this part, because when it's like equal to each other and then it's to the power of x plus something or x something, when it's to the power of x, you know it's a common base. Common base. So to be able to make these into something you can solve, you have to make these into common base so the tops can like be equal to each other. So check this out. 27 to the power of what is its simplest form? Okay, so not 27 to the power of what, but what to the power of what is 27 in the simplest form? I think I can go with 3. So 3 to the power of 3 is 27, right? So that's times x plus 5, because we want to free them. We want to make a common base, right? So 3 to the power of 2 x plus 2, right? Now we just multiply these together, and then you got the 3 to the power of 3x plus 5 equals to 3 to the power of 2x plus, so not 5, 15, and then you got 4, right? So this, since they're common base, they're just equal to each other, so you could just drag them out here. 3x plus 15 equals to 2x plus 4. So you just drag them out because you have a common base, right? And now you just solve them. So you just like drag it this way, you bring the 2 to the other side, you bring like an x, it's x, and then you bring I'd say bring the 15 over here. So you just do a negative 11. Yeah, that's the answer. The answer is negative 11. All right. Let's do inverses because these things are tricky. All right. So with inverses, you normally just switch it. You got, negative 2 log 3 base 3, and then you got x minus 1. You just switch x for y and y for x, because f of x is y and x is x. So you just swap them. This would be x and this would be y. It just equals negative 2 log 3 y minus 1. There we go. Now we're seeing some commonality. All right, what do we do here? Oh boy. Now this one goes about like this, right? You got your basic negative 2 divided by negative 2. Both sides are divided by negative 2. Everything's fine and dandy. 1 over 2x minus negative 1 over 2x, right? And then you put that equal to your new log 3y minus 1. Oh boy. These were tricky at first because they were inverses, but no need to worry, as you can now bring you could straight up just bring the entire 3 to the others. You could just do this. You could do y minus 1 equals, you got the 3 from the base, so you just put it to the power of negative 1 over 2x, because it's equal to the log, right? So you could legally do this. You're allowed to do this, like in math laws, you could do this. And essentially what happens is, well, you've got this, right? And you can just bring this to the other side. So it's just y, this is y, right? We bring the 1 to the other side, so it's just y equals, right, 1 over, right, 3 to the power of 1 over 2x, right, plus 1. You know why? Because there is a negative here. This negative exponent has flipped this thing and made it positive, but in the denominator, right? And the y has come over, sorry, and the negative 1 has come over here, which is plus 1. Now we have this. We have our final answer, which is going to be f to the power of negative 1 equals 1 over 3 to the power of 1 over 2x plus 1. That is our final answer, check mark. There we go. Oh my god, that was a long one, boys. Now it's time for the second equation that we're going to solve, which is 5ln x minus 9 plus 11 equals 29. All right. First, we bring over the constant that I see here because constants need to go. 5ln 5x minus 9. You bring the constant over, you don't got that anymore. You got 15. Right, now you just divide this by 5, you divide this by 5. Now you got ln 5x minus 9 equals 3. There we go. All right. Now what? This is technically e to the power of 3 because we've got an ln here, right? So we can free this ln, right? We could go 5x minus 9 equals e to the power of 3, right? Because ln can make this into an e, because ln, natural log, is e to the power of x, right? So that gives us the right to make this e to the power of 3 to the other side. So now we have a dilemma. We need to move, we have got 5x, right? And we need to move the constant again, right? And we put this here, we got 9. Okay, now what? We have to divide by 5, divide this by 5, divide this by 5. And now we got a big fat answer. We got x equals e to the power of 3 plus 9 over 5. That is our answer. And if you want a calculator, then it's roughly 5.81 or 5.82. There you go. All right. Now we have to move on to graphing. Graphing is really important because, well, exponential functions can be very hard. Initially, I had a problem with this as well, with graphing and such. It's not that hard, but there are some key things that you have to remember. Like how these asymptotes for the exponential functions, they're going to be horizontal. So you got a 4 here, and that's your horizontal asymptote. So this is y equal, oh boy, that looks like a bad y. Y equals -4, right? So you got 4 here, you got -4 here. Ooh, squiggly line, oops. All right, now you got your domain, right? Your domain should be always for the exponentials, right? It's always negative infinity, positive infinity. That is a bad infinity. Positive infinity, negative infinity, positive infinity, right? And your range should be where it's coming from. So first, I would actually recommend putting down your points. Your points should be found through your, what's it called? Your formula. This is the formula thingy. X over b plus h, and then you got a times y plus k, right? Use this to find points. Right. Okay. So now it's just important to know your parent points so you can plug it in for x and y. So parent for exponential functions is, I believe, it is 1, 0, R1. 1, 0, R1, 0, 1, R1, 0. Wait up. Okay, this is important. Yes, allow me to correct myself. It is 0, 1, right? R1. All right, now our R is this thing. This is our R, right? So we got 0, 1, right? And we got 3, 1. Now we just plug this in to this equation, right? And we got it, right? So here, I'll just bring it down here. I'll make some space, right? We got our x, which is 0. We got our b, which is 1, because there's nothing here. There's not a negative x on top of here. It's to the power. We don't have anything. We don't have any negatives here. It's just positive. And it's not 2x or 3x or 5x. It's just x. So it's 1. So 0 over 1 is always 0. So we got 0 plus, what's our h? We don't have an h. We don't have an h. So that means that the h is 1. What? Okay. Yes, 1. We got 1. And then we got, what else? We got our a. We got 2. We got 2. And then we got our y, which is, we got a y, which is 1. Right, so ay 2 is 3. So we got 3 plus k, 3 minus, which is -1. So our first point is -1, 1 minus 1. So it'd be here, 1 minus 1. Exactly right here. So now what we have to do is find our other point, which is going to be found like this. Our other parent point is 3 and 1, so we got 3 as our x, 3 over 1, 3, 3 plus 1 is 4, we got 4, and then we got, what else? We got 1, this is 1, this is a, y, so 1. We got 2 plus, so it's 2 plus negative 4, negative 2. There we go. All right. Whoa, this is something completely different. I'm doing something wrong. Oh boy. All right, let's see where I got wrong. All right, anyway, the graph of this equation kind of goes like this. I'm going to cover this more in depth in a later video. I just realized that I'm hitting the 20-minute mark, which is not okay. So let's just graph this here. We got this going through 2, going through 0.5. It goes up, right? And then we got a range of -4, right, to infinity. All right, that is our range. I will close up this video for now. I will be posting more review content later. Bye-bye. I'm sorry for the long video.